So we're here to talk today about worms and soil health, and I am so excited and pleased to have Marc-André Selosse here with us today. Marc-André is a professor of mycology, I'm sure I'll get this wrong, at the Natural History Museum in Paris and at Gdansk, which I can't say, in Poland, and at Kunming in China. And he is an absolutely brilliant speaker. They have a great phrase in French, which is they vulgarize science. We popularize science and they vulgarize science, which I think is much more fun. So Marc-André is going to speak for about half an hour on the importance of soil health and the soil food web and worms contribution. And then we have Jules here next. Jules is co-owner of Ham Street Vineyard, which is a biodynamic vineyard in the UK, one of the few certified biodynamic vineyards in the UK. And then after that, we have Rob, who is from Vinescapes. Vinescapes is one of the leading viticultural consultancies in the UK, and they are very involved with regenerative viticulture. I should probably say who I am. I forgot that bit. I'm Becky Sykes. I'm Programme Director of the Regenerative Viticulture Foundation, and we are a global non-profit, and we work to inspire grape growers for wine around the world to use more regenerative practices. So, yes, I'm the wine lady, which is quite a nice job. Okay, so over to Marc-André, who's going to start us off. Sorry, I might be going the wrong way with the slides. That one, is that forward? Try the red button. No, oh no, oh.
It's coming. Oh. Okay, so I'm sorry this conference will be held in Franglish. So if you feel uncomfortable with the translation of some words, you just ask Betsy, she will translate for you. Well, the fact is that when we think of soil, we often don't realize that soil is alive, that soil is living. And one of the reasons is that the life in soil is mainly made of microbes. And those microbes, they are pervasive in soil. They, for example, are mushrooms and fungi. When you see fungi, you cannot imagine that they are microbes, but you have to imagine that what you see from them is what is producing spores. And spores are very small cells that germinate into filaments, which are growing, ramifying, with ramification that connect together to perform a network which is called a mycelium. And mycelium of fungi is something that is pervasive in soil and which you cannot see because the hyphae, the filaments are 1/1000th of a millimeter, but you can smell it. Very often the soil is having a distinctive smell of fungus, exactly as when you prepare your rosé mushroom for the food. This smell of octanol is something that you can smell in soil. And also sometimes in wine, but it's not a good news. Bacteria are even smaller than the filaments of the fungi. They are 10 times smaller, but they still are very abundant in soil, and they give a smell to soil. Filamentous bacteria, the so-called actinobacteria, they are producing geosmin. Geosmin is the soil smell. When it's smelling soil, it's geosmin. And so you don't see them, but again, they are so abundant that they shape the smell of soil. Okay, there are also other things, such as amebas. Doesn't work a lot. Oh yes, they are coming slowly. This is a normal speed view of an amoeba. Those are big cells, a bit bigger than the filaments of the fungi, but still it's microbial, crawling in soil and eating bacteria. And the way the cell is able to reshape and change the shape is allowing them both to harvest food, ingest food, and to move in the soil. All that is making a soil that is mostly microbial. In 1 gram of fertile soil, you have 1 million of bacteria belonging to thousands of species. 1,000 of species of fungi and hundreds of amoeba species. I don't count the virus because we still have a poor knowledge of virus. Depending on the estimation, it's considered that on Earth, a quarter to 60% of the species of organisms are living in soil. And it means that in terrestrial ecosystems, between 1/2 and 55% of the biomass is underground. And if you add the dead organic matter to the living organic matter, you end up with 60 to 90% of the total organic matter in soil. It means that soil is very rich in organic matter, soil is very rich in life. But you know, this list of who is in soil, I should have been adding a bit of animals, I shall come back on that, and a bit of roots, okay? But this is only the list of the players. And when you play, you don't mind the list of the players. What you want is to see the play, the game, okay? So, and the game is that those guys, they are making actions in soil which actually are just preparing the soil. The first thing is that dead organic matter sooner or later becomes decomposed. And decomposition, it's how fungi, bacteria, or even some animals are eating the dead organic matter to live, to grow. But whenever you are living on a substrate, part of it is used for growth, but think of what you eat. Most of it is just destroyed to recover the energy by way of respiration and to be active. And you produce waste due to respiration, which is not only CO2, but also the nitrogen, the phosphorus, the sulfur that was attached to the molecules you were just breaking with oxygen to release energy. So the fact you respire is driving you to produce urine. And it's the same for the soil organism and microorganisms. They release nitrogen, phosphorus, etc. from organic matter, which is just available for plant. So decomposition is also producing fertility. Realize also something, which is that the rocks, the pieces of rock in the soil, they undergo a destruction which is far more active with microbial life than without it. If you put for 6 months a piece of apatite, a mineral which is rich in phosphorus, 6 months in water, after 6 months it's nearly the same. Now add a few drops of juice of soil before you wait for 6 months. Then at that point you end up after 6 months with a fully altered surface, because there are microbes that are just dissolving the rocks to get additional phosphorus, additional iron, additional calcium. It's the way they extract their components from soil. So fungi and bacteria from the soil, some of them are releasing a lot of minerals and especially oligo-elements from the rocks, and a bit of that is flowing to the plant. So once again, exactly as for organic matter, minerals, they are broken down by the living things in the soil, and the result is fertility. Let me add that even gas entering soil from the atmosphere are used by the life of soil. For example, in the soil, some organisms are respiring, so they use the oxygen coming from the atmosphere. They also, some of them, use the nitrogen from the atmosphere, such as, for example, those beans here between the row of vines. The legumes, the plants called legumes, they are symbiotic. They live in association with those bacteria that also exist free living in soil, which are able, so you have a root of a legume with those pinkish outgrowths where the bacteria are hosted and fed with sugar from photosynthesis. And those bacteria, they are able to use atmospheric nitrogen entering the soil to make nitrogen under the form of amino acid, which is also used by the plant. And whenever those bacteria and those plants are going to death, they decompose, and their nitrogen is released in the soil in a form that is now available for plant. So it's a long way, sorry, but the fact is that even atmospheric nitrogen is sooner or later converted into fertility. I think it's the take-home message from this story. Soil is made of organic matter, atmosphere, and rock pieces. All of those sooner or later will be destroyed by life of soil with a release of fertility. That's the first thing. Now, the fertility is not directly available to the roots of the plants. It's channeled by fungi to the roots. Here you have an example of roots of wines, and you can see that inside the roots, in blue in this case, stained, you have filaments of fungi which enter some cells and ramify into some cells or make arbuscules. Most plants' roots are harboring fungi, which also grow in soil. And we call those roots, technically, and this is the topic of research of my teams in Paris and in Gdańsk and in Kunming, we are working on this association between soil, fungi, and roots. The roots is a bit of a root, rhiza in Greek, but also it's fungus, myco in Greek. So we work on those associations where soil fungi are interacting with plants' roots. Interaction is not an easy job. Okay. Too much. Okay. You can see here this root connected to a mycelium of a fungus. Okay. The root is not a true root. It's a mycorrhiza. It's an association with a fungus, but you don't see it at this scale within the root. And this association between the soil fungus and the root is just a way for the plant to harvest the fertility of soil. The plant is giving sugar to the fungus, and in exchange, the fungus is collecting water and all this fertility we prepared together before to the plant. So even the channeling of the fertility to the plant is a life story. In addition, and finally, those fungi are also protecting the roots. Let me, for example, show you how the mycorrhizal association of fungus, Rhizophagus intraradices on wines, is protecting against the nematode Xiphinema index. This nematode is a root parasite. It's not very dangerous, but it's propagating a virus, the virus of Cournouet, short notes of wines. It's an illness that is making shorter nodes between the leaves. Someone can help in English?
Alistair, can you help? No?
It's a French word.
It's something without name in English.
Sorry.
You mean it's a French problem and not an English one? So the nematode is not very dangerous, but it's propagating a virus which is very, very reducing the production. And if you see after inoculation of the illness of the nematode, the non-mycorrhizal roots, they get ill and more ill, while the mycorrhizal one, the one with the fungus, the illness is disappearing. And on those ones, roots, which are rootstocks, which are mycorrhizal. If you look at the level of mycorrhizal interaction and the level of illness, you see that the more fungus is on the root, the less the roots are ill because of the nematode. So it's also something which is quantitative. It's not a yes or no. It's just the more mycorrhizal, the more protected. So it's a wonderful story where the roots, they get food and a partial protection. Partial, not full, but partial protection against illness. Now, the life of soil is not only making the fertility, channeling the fertility to roots which are protected against illness, but also life is foaming the soil. The soil is a foam. You don't realize that, huh? But the soil is a permanently foamed material by life. There are pores, and where do the pores, which are very important for air and gas, coming from? They come from life. From life to death. I mean, when a nematode or a worm is making a hole, it's a hole. But whenever a root or a filament of the fungus is going to death, it's making a hole, a pore. So here it's a wonderful one from earthworm. Of course, it's an opening, and that's the way water is entering in soil. The big animals, and especially the earthworms, they are making the spores that allow the water to flow into the soil. You see here on the right that the more biomass of earthworms you have, the more penetration of water you have. And if you take a soil without any worm and add worm to it, you can increase the available water for plants by 20%, by 25% in 10 years. So the story is that the big pores are very useful to allow the water to flow in the soil, but they are useless to retain it. What kind of pores in the soil allow to retain the water? The teeny ones that allow capillarity to retain the water. And who is doing the small pores? The one retaining water. But the microbes. The pores which are very effective in retaining water are the pores of dead filaments of fungi, the pores created by the circulation of amoebas, the pores due to circulation of bacteria or dead bacteria. This is the kind of pores which are retaining water. And you know, life is making pores in soil of all sizes, the big one for entrance of water, the small ones for retention of water, and it's making good pores. So what are good pores and what are bad pores? A good pore is something stable. And life is making stable pores, because first it's intrusive. So they tap, you know, they compact the walls of the pore by penetration of a root growing or a filament of fungus growing or penetration of the amoeba. It's compacting the walls. Second, it's glued. The grains of the walls of the pore are glued by the organic matter, the mucus of an earthworm, the sheet of an amoeba, because amoeba, they are pooing. And when they poo, it's a glue for, yeah, but yours. It's funny, of course, but it's true. Sorry. A dead filament or a dead root is also delivering a lot of organic matter that is gluing the surface of the pores, and that's a pore. Compacted and glued by life. This is how soil is also having water. So, of course, when you think of foaming and mixing and making this foam of atmosphere and matter and solid material, which is soil, you of course think of the earthworm, and also you also think of the ability to mix the component of soil. The fact is that if we focus on earthworms, they are indeed making a lot of mixing and making pores by different ways. We often think that they eat organic matter. It's true and a bit not exact in terms of what they digest. Most of the organic matter of soil is not digestible for earthworms. For example, cellulose, they hardly digest it. Lignin, they don't at all. And this is already 90% of the organic matter of soil. If they eat organic matter of soil, it's because it's colonized by microbes, especially bacteria. And they can digest bacteria, and to some extent, fungi. For this, they need to grind delicately the organic matter to extract the juice of bacteria. So it means a lot of grinding. How can you grind when you don't have teeth? Yeah, that's it. You should ask your chickens, and they will answer you. I have no teeth, but I can grind the grains by way of a gizzard. I'm happy that you pronounce it, because I didn't know the pronunciation in English. Un gésier. So, of course, there is one gizzard here. You cannot do a salad with that, but there is one. And to grind, of course, you need to have something hard into the gizzard, and the chicken, they are eating some pieces of stone. It's sand grains for the worms. But then starts the disaster. When you finally grind the organic matter made of rests of remains of any plant, you release the tannins, the terpenes, the alkaloids, all the toxins that the plant have that makes that most plants are not edible to anyone. So this is something that could kill an earthworm. The way they inactivate that is that they eat a lot of clay. And clay is just linking to tannins, terpenes, alkaloids, and impeding them from diffusing inside the earthworm. The result is that with sand and clay, which are very dense, the animal is eating 25 its weight a day. It's because it's more dense, but it's a lot of things. So if you are doing that, you need to poo at least once a day. But if you're living in a tube, don't poo in the tube. Because then you would make the tube glued and no, it's basic, but you don't realize that. But the fact is that the animal is pooing on the surface. In the poo, there is organic matter because I told you it doesn't digest all the organic matter, but it's now finely mixed with clay. That's why when you have a fresh poo of worm, it's very clayish. You can feel it. But if you really press it, you will feel the grains of sand also. So it's a wonderful mix. This mix is also partly porous because when it's pooed, there is pieces of, not everything is linked, so there is a bit of air. So it's a wonderful way of not only foaming, but also mixing everything. And the final issue is that here there is grinded organic matter. If it's grinded, it's more accessible to microbes. So sooner or later, microbes will proliferate into the poo, and few days after, this is the perfect food because there is sand, clay, and bacteria. There is this myth that in the poo there are more bacteria than in the food. It's fully false. I don't know if you have it in England, but in France, I know even at the university, we say, the worms, they enhance proliferation of bacteria, which is true. In the poo, there are more bacteria than in what they eat. It's a nonsense. It couldn't be because they digest bacteria. But their poo is a perfect substrate for recolonization and proliferation of bacteria. And so the day after, they can even eat old poo. They are just rich in everything, and they start again to mix it, foam it, etc., etc. But this is a general rule. Here on this table, you have different substrates of leaves, and horizontally different species of animals. And you see the poo. If you look at the poo, it looks exactly as the leaf, but grinded. What do they digest? Most animals, they don't digest the organic matter. They grind it to recover the juice of the microbes. So the poo looks like what they eat, grinded. Because they don't digest what they eat. They eat the inhabitants of that. So it's a general rule. Don't think of the animals as the agent of decomposition. They are eating the microbial agents of decomposition. But in their poo, there is a proliferation of microbes. So in a way, they help the action of microbes, and they contribute by this way to decomposition. So we need life in soil if we want the soil to perform all its activities. How can we have that? The first thing is that pesticides are not good at all for life of soil. Here is an example of something which is a delicate story, glyphosate. And you will see that my position here is very in gray, not in white or black. You can see here the evidence that for cocoon hatching of worms, glyphosate has a negative action. So glyphosate is normally killing herbs, but it's in the shoot against herbs, some worms are killed. We face here one of those components that is in our practice is harming the life of soil. Yet I have to tell you something very important. Till, I shall come back on that, is very more dangerous for earthworms and life of soil than glyphosate. So we should avoid glyphosate, but the first thing we have to avoid is till, or tillage, if you prefer. Well, in English, it's till also as well, so sorry. I know yesterday you told me to say tillage, sorry. So if you see the number of individual when there is tillage or no tillage or superficial tillage, you can see that there is a clear impact. And if I have to choose, I know from many papers and many research that tillage is more harming the life of soil and, for example, the earthworm than glyphosate. So if you tell me I need glyphosate to manage non-tillage, okay, transiently, it's good. In the future, sooner or later, we'll have to escape also glyphosate. But for now, this is the first cause of life problem and earthworms survival problems. This is the second one. But if you fix this one, you already get a much more living soil with all the functions we described. And finally, what we need also is to have a permanent cover of the ground. Because first, many living beings in soil, they rely, like the fungi forming mycorrhizae, they rely on roots. So you don't, if you have a bare soil, you don't have the plants feeding the life of soil. What's more, it's impeding erosion. And what's more, those plants, when they go to death or when they lose leaf, they are just giving to the soil the organic matter that is so necessary to feed the life of soil, but also to act as a glue on the soil to stabilize the porosity and to limit the erosion. So, if I summarize, limiting the tilling, covering always the soil with vegetation, and limiting the impact of pesticides or the use of pesticides. Those are the three things we have to try to do. I fully acknowledge that it's not always easy, and that you can make your transition without pesticides. This is organic. Or make your transition without tillage. This is regenerative agriculture. And that you cannot do everything in one step. At least do one thing, that's great. Do what you can, because it's easier to speak here than to be a farmer. I fully realize that. But please think of that. Soil where never receiving pesticides, never bare, never uncovered with vegetation, and never undergoing tillage before we came. So whenever we can reduce those three things, we will support the life of soil and the life of earthworms. And that's my message for today.
Thank you so much to Marc-André. So there's nothing like a bit of controversy for first thing in the morning, is there? We will have another hour session after this where you can come and ask Marc-André as many questions as you like. So please do hang about for that as well. And we're actually really pleased to see so many of you here. We're very aware that Andy Cato is on the main stage at the moment, but I think he's probably a bit tired after Glastonbury. So, you're better off being here, I think. So anyway, so now we are going to hopefully move on to Jules when his slides magically appear.
Let's see if this works. Oh, let's go.
Keep going, maybe.
There we go. Right. Well, thank you, Marc-André. That was absolutely fascinating and a really hard act to follow. And can I also just say a massive privilege to be on stage here at Groundswell, talking a little bit about what we do. So as Becky said, my name's Jules. I'm from Ham Street Wines in Kent. There's a little bit of information up on the screen for you to read through. I'll talk a little bit about the practical application of how we've managed soil health and improved our worm populations in the vineyard context. And this is very much about our experience of what we've trialed. It's not necessarily scientific, but it's our observations in what we've seen in our vineyard approach. But I want to go back and focus on the point here at the bottom of this slide, regenerative from day 2. When we and worms really played a key role in that. When we planted Ham Street Wines back in 2019, when we were going into it, we were very much focusing on, well, can we make this a sustainable business? What sort of varieties do we need to plant? And all the practicalities that go into planting a vineyard. We had a natural inclination to farming organically, but speaking to a lot of the consultants or all of them that we were speaking to at the time, the advice was very much go very conventional in your setup. And so we did. When we planted the vineyard, we did a couple of rounds of tillage, one heavy till, one shallower till. We also sprayed glyphosate on the soil and applied some fertilizers. So I can't believe I admitted that in front of a crowd at Groundswell. But after we did that, we went out and we dug a soil pit immediately after planting, and then also later in the season, and we realized the soil was just dead. There were no worms. It was smelling not particularly interesting at all, and the structure was poor, and so our natural inclination, like I said, was to go organic, and so we just thought, this is completely the wrong way of farming. We need to do something different. We want life in our soils. And so we began the conversion to organics in that same year. And we're now certified biodynamic, so we've gone a little bit further than that. So I've now put up a slide that kind of sets out our regenerative worm-first approach, and I'll focus in on a few aspects of this. Like I said, we focus and we work in a biodynamic system. But we really take a very holistic approach in terms of managing our soil health and also the general vineyard health. And I think the key point here is you need to really think about things in a very holistic way. All of these aspects interplay, and they all have a positive or can have a positive impact on each other. And so this Venn diagram sets out those practices. And I think, there's a lot of overlap between these areas. Some of the things sit in both camps. But I'll just focus in a little bit on a couple of aspects. So first is plant health. When we think about soil health, we rightly think about the soil structure and the composts and things that we're adding. But I think plant health is just as important. If you have good plant health, then those vines, your crop is going to form better relationships with the mycorrhizae, fungi and the soil life, and get a better nutrient exchange. It's also going to do things like secrete root exudates into the soil, which is going to feed that biology further. It's going to put down better roots and improve the soil structure that way. So focusing on the plant health can really help accelerate that soil regeneration. It is also key to helping you grow more resilient crops that allow you to then apply less in the way of anything harmful, any fungicides, for example. So we do things like we follow and use sap analysis to really dial in the plant nutrition that we're using. But also, and I credit biodynamics with this, we use things like plant teas to actually improve the vine health and reduce our use of things like copper. So, for example, horsetail tea has a real high silica content, and that improves the leaf cell wall and means that it's more resistant to mildew. And yeah, why don't we go there to organics and biodynamics? I sometimes hear that you can't be regenerative following an organic system, and I think in our experience, we would disagree. One of the big reasons for people saying that is that you are constrained to using things like copper in your fungicidal program, and like I say, we've been able to really reduce our levels of copper down to a very, very low rate by following this plant health approach. Using the sap analysis to look at nutrition, using the plant teas as well, and also compost teas to provide a bit of competition for the pathogens that might exist in your vineyard, but also to improve that plant health and make it more resilient. Tillage. That is the other reason that people often say that organics won't necessarily work in a vineyard context. Typically and historically, people have managed the undivine layer by doing an undivine cultivation. We did that again for the first couple of seasons, but we've now moved to a kind of a no-till system under the vine. We use an undivine strimmer, which allows us to clear that cover under the vine as well. And you might also be thinking, well, we're going to have to do loads of tractor passes as well to keep that down throughout the season. Again, you'll see this photo of our dog, Peanut, looking out into the vineyard. Everyone's got to have a vineyard dog. We've let the cover crop in that photo grow really long, and we typically let it grow right up into the canopy, up until about flowering, and then we'll mow it back. And the benefits of that are huge. The cover crop is really growing and really establishing that root structure and getting it to its maximum point. And you're also mowing it at a time when the seeds are developing on the cover crop, and actually it's going to be a lot less vigorous later in the season when it comes back. And finally, it's going to put down a big mulch on top of the soil that's going to feed those worms and feed that soil life. So again, we found that following that no-till approach under the vine, we're able to limit the number of tractor passes in actually managing the growth under the vine. I've said min-till on this slide because we have established cover crops, and we've tried that in a couple of different ways. First with a light till, and then with a direct drill. Our experience has been the direct drill didn't really work in our context. Probably a little bit too much competition for those seeds. And actually, you've got to think about, well, the benefits of establishing that cover crop probably outweigh doing a very light till. And here we're talking, a couple of centimeters. So I think you've got to think about the context of your site and whether tillage is the right approach. The other thing I'll just quickly touch on is vermicasts. So we have used vermicasts in the vineyard, done some trials on them as well, applying those directly under the vine in small quantities. And we've seen some really interesting results. We've seen the Brix level on those vines actually increase by about a degree, which is the equivalent to 0.6% potential alcohol, which in our climate, not every summer is like this one. You really want to maximize the ripeness of the crop. So I think vermicasts can work really well. We have stopped using it though, because I think we're a very small operation. We've got to really manage our costs. And I think doing things like building the Johnson Sioux bioreactor, using that in our system, the BD 500 biodynamic composts and cover crops, all of those things are providing a really good role in improving soil health and building worm populations in our soil. And so through all of this, we've seen some great results, and I'm not going to claim that we're getting everything perfect, but we've seen our organic matter nearly double over the time we've been farming. We've kept our copper levels in the soil stable. They haven't increased despite us working in this organic system. And most importantly, we've seen our worm counts increase massively from basically none to around 20 to 30 in a spadeful. So extrapolate that up to a meter. It's a very decent volume. And we are, working across all of these things to continue improving the soil health. So when you're thinking about soil health and worms, think about the whole context. Think about your plant health, your soil health, and your biodiversity, like I've got on the slide, and get out, dig a spadeful of soil, see what's in there, and start taking this approach. Thank you.
Excellent. Thank you so much, Jules. It's great to hear that what it looks like in practice, what Marc-André is saying, and then see how you're actually managing to improve your soil health. So next we've got Rob. Rob is from Vinescapes. Rob was named Sustainable Viticulturist of the Year last year by WineGB. So we're very pleased to have him here. So over to you, Rob. Thank you.
Thank you. Thank you, guys. Thank you. Yes, I'm Rob. I'm from Vinescapes. I'm a viticulturist here in the UK. We farm vineyards all across South England and East Anglia. So we've got hundreds of hectares from Cornwall all the way through South England and up to East Anglia. With that comes a lot of different microclimates, a lot of different aspects, a lot of different vineyard sizes, and most importantly, a lot of different soils. We have clay, chalk, we have limestones, we have sandstones, we have green sands, and we're tasked with our clients about building fertility into these systems and building fertility with nature in mind along the way. So when we start off, we have two options of planting a vineyard. We take the more regenerative approach where possible, where we hand plant straight into the ground. This means we leave the soil structure in place and maintain that earthworm population as is. That's really, really important about what we do straight off the bat. For the larger sites that we manage, we have to use a conventional preparation method. And what that involves is machine planting. Now, when you machine plant and you conventionally prepare a field, you're essentially going back to basics and you start from scratch. Bare soils, like Jules described, not much life. So how quickly can we build fertility back into these soils? Well, we think between 3 and 5 years, we can take a bare soil and bring it back to life into a thriving ecosystem. So the picture on the left or right, whichever way you're facing, is a vineyard that we planted in Surrey in 2023. So you can imagine 2023, you can imagine bare soils, you can imagine dusty ground, and we've used things like cover crops to bring this vineyard to life, to build the fertility into this system, organic matter. We've used a brassica mix here that's going to directly dig down into those lower horizons with its tap roots, improving the drainage and doing lots of important, crucial things. And we're bringing life back to these soils. We're letting nature do it. We're letting nature do the work for us, which is really important. What we're trying to do, and the snapshot of the worm farm on the other side, is we're trying to get nutrient cycling happening in the lower horizons. Vine roots dig down deep, 1.5 meters, 2 meters at times. And we want life in those lower horizons of the soil, as well as the top, so that we can enrich our plants, and our plants can dig for nutrients and water and have access to all the good stuff to make more resilience and build resilience into our vineyard. It's important when we grow crops to do this with respect to life in the soil at all times. So a few concepts of reducing tillage are crucial to what we try and do. Other systems that we have tend to have a more conventionally grass cover in the rows, but we add organic matter back into the soil. We're doing that to enrich in the earthworm life, to improve the soil health directly under the soil. We want 100% of our field to be healthy. We don't just want the 25% of the land we use for our row crops to be healthy. We want 100%. We want those roots to dig into the alleys and to be happy. We use organic mulches. We use biofertilizers, crop digestates. Feed the soil, and the soil microbiome will feed the plant. So here you can see we've added compost under the vine here. That's going to break down and rot and cover any bare soil. It's really, really important for a balanced system that we get this right. Here you can see a vineyard that we took on that used to till under the vine, which is the conventional way of getting rid of weeds and everything like that. But we've allowed the natural vegetation here to take hold. And we were lucky in this instance that it was clovers that took hold. And clovers are great companion plants under the vine for grapevines. They're also loved by earthworms. So the soil pits that we dug, and we dig soil pits at least twice a year to look at the earthworms, to see what we're doing is working or not working. How can we improve? How can we change? And they loved this system. Our earthworm counts were phenomenal in these types of systems. From a viticultural, from a fruit growing perspective, what you can see here is contradictory to what a lot of the common methods are of keeping bare soils under the ground. Bare soils to reduce humidity for ripening crops. What we've seen here by keeping our under vine vegetation low is we don't get this problem with humidity. We don't get this problem with competition in mature vines. And you can ripen a pretty healthy, happy crop in this way. We're going to explore in the future ways of seeding under vine and what other companion plants can work under there that are going to enrich the soil life. Things, herbs, different types of plants that we can explore. We're going to keep trying until we get it right. Interestingly, when you're in a mature vineyard and you find pockets or any field and you have pockets of poor areas, one of the most common denominators in those areas is poor soil health. So one of the things that we're trying to do by eliminating tillage and reducing any chemical inputs is to try and even out the field and to have 100% of our field happy and flourishing. So the kind of 3 rules that Marc-André talked about, I think we're kind of on the same page a little bit, is reducing your tillage and reducing your compaction. That's not damaging any earthworm habitats or burrows or anything like that. These earthworms are going to help improve your soil health, and your soils are going to help stronger vines. Feed that soil life as well with things like organic matter, things, compost, mulches. That's going to create a real thriving earthworm population. And lastly, we stopped using chemical fertilizers a long time ago, but it's about maintaining an adequate pH in that soil as well, and also checking your moisture levels to make sure that you've created a real worm-friendly environment in whatever field or whatever crop. I think this applies to most. That's really, really going to be beneficial for the future of your crop. So thank you. That's it from me.
So thank you to Rob. Well, thank you to all our wonderful panellists. So we do have time for some questions. We weren't sure whether we were going to or not, but we do have time for questions. I'm sure there are some burning questions out there. I can see one hand up over on the left-hand side. And one there, yeah. So the first one's just there.
Good morning. Marc-André, really interested, and thank you for that. I, like Becky, am a non-profit organisation because I'm a farmer. But a question for you, please. The slide you had that compared tillage with glyphosate, what was the timing that study was done after the tillage or the spraying? What was the time lapse?
Okay, what you mean here is the resilience, okay? That is the time you need to come back to previous level of abundance of a given organism after the disturbance. I'd say that it's not very clear because it mainly depends on the community of worms, okay? So on average, I would say it's the same time to come back to the previous level. On average. But if you take a fertile soil, it's just, I make a disturbance and I look how it comes back. But on a soil in a vineyard, you have additional actions that come after, like, for example, entering the field with your tractor to cure, and then you have compaction. So when you add that up, when you add the other treatments you put on the soil or on the vines, the resilience is not the same. It's faster with glyphosate than with tillage. If you only have a disturbance and wait for what will happening in a kind of experimental design, it's the same time. If you add up all the other stress that are linked to the way you manage your field, then glyphosate is having shorter resilience than tillage. I hate this idea because I don't like the using of chemicals, but I'm sorry, it's the data. And science is not meant to make you happy. It's just meant to give the data.
Lovely. We had there were two hands on this side. There's one just kind of fourth row back. Thank you.
Hello. Just a question for Marc-André again. Sorry. Just with regard to earthworms in grasslands, anecdotally, I generally find a lot more earthworms in temporary grass that's maybe 2 years old and has crop residues within it from the previous crop, compared to a permanent pasture. And the permanent pasture on the permanent grass, which is grazed, is livestock on it, is uncompacted. Is that because the permanent pasture is more fungal and it's got low bacterial presence, or is there something else going on?
It's hard for me to answer because I have no myself idea of, in general, what would be the outcome of a comparison between permanent and recent grassland. So I don't have the data, and when I hear you, I can't comment much on the mechanism behind. But you have to know, you will kill me, Betsy, that too much of earthworms is not necessarily good news. It's a matter of the good level, It's like alcohol in wine. Too low alcohol, it's not good. Too high alcohol, it's not perfect either. So at some point, you have a minimal level of earthworm to achieve. But the maximal, it's not necessarily good to have, the goal is not to have the most. It's true in the context of tillage or current soil in agriculture where we have too low levels. So in this context, the more we have, the best it is. But in absolute, in non-managed areas, the level of earthworm is another story, okay? So it may be that whenever you make your comparison between a recent or a permanent grassland, you are well above the necessary level, and that in details, the difference you have are not very relevant to the fact that the main functions are already achieved. So it's a bit of a complex answer, but I have to say that I don't have the data to comment more. My ignorance here.
Thank you. There was someone just behind there, had their hand up for quite a long time. Thank you.
This is probably a question for Andre. I'm a vegetable farmer to a certain extent, so having to use tillage to produce onions, potatoes, carrots. I look around here and I'm looking for shortcuts, and there's a plethora of people selling mycorrhizae, bacteria, and all these things. In a situation where you have to use a level of cultivation to achieve some of those crops in my rotation. I have 20 crops in my rotation, but onions and potatoes and carrots are part of that. Are there any? We like shortcuts. Are there any out of a bottle or a can that can help that situation?
Well, it's true that there are some cultures in which you will disturb the soil. For example, potatoes, it's obvious. So, still you can minimize the disturbance. And I will tell you why I think of the disturbance here when I will elaborate my answer. But I saw in the northern France and southern Belgium the technical names in English, it will be a maze. But whenever you harvest your potatoes, you are building the
Ridge. I think.
For the next year. At the same time, you are sowing on that. So for the whole winter time, you'll have the vegetation growing on that. Then you glyphosate, and you introduce the potatoes into the
Ridge
that were already prepared. So it means that you disturb once and not more than once. But I say always, whenever we can, we should not. But whenever we can. And so I think that before thinking of inoculants, before thinking of buying bacteria for soil or mycorrhizal fungi, you have to think that they will develop if there is permanent cover, limited disturbance, and to some extent a good level of organic fertilizers and less mineral fertilizers. So that's the basis. And with this basis, you can even count on your local diversity to recover. That's the resilience, as was mentioned, on still a longer term. But within few years, you may wake up the sleeping beauties that are in your soil just by limiting disturbance of the soil, permanent cover, and as much as possible, organic fertilization. So don't run to buy. And if you run to buy something, think that it will be efficient only in the framework of new or different techniques of culture.
Can I just add to that quickly as well? I think what we've done as well for putting seeds into the ground is use a Johnson-Su bioreactor. That's something you can make yourself. You don't need to go out and buy anything for that. And I'd always encourage you to think about that. You build it yourself. You get the right carbon-nitrogen ratio. We use prunings and cuttings from our cover crop to do that. So it's completely closed loop. Then treat your seeds with that. Before you put them into the ground, you're already putting in some good soil life into the soil and boosting it. So there's ways to do this very low cost as well.
Low cost and local, which means adapted to the climate and the soil. It's a detail, but whenever you buy something, is it for your soil? Is it for your climate? And by the way, is it for your harvest that you want to do, for the plant you want to grow?
I'm so sorry we've run out of time for questions. And there was someone at the back really wanted to ask one. And I really want to invite people to stay and come and ask Marc-André questions, and the others, sorry, and Rob and Jules, clearly, sorry. He is our superstar today. And thank you all so much. Can we just say a massive thank you to our speakers, and please do stay.